Hello everyone. Welcome to Blacksnwhite.com. Imagine, you are the mayor of a town tasked with setting up communication systems in 3 different scenarios, connecting homes within your town, linking multiple towns in your region, and managing communications across the entire country. Each scenarios require a different scale of network LAN for the local community men, for the regional links, and WAN for nationwide connections. How would you decide which type of network to use in each scenario to ensure efficient and effective communications? This is where the network categories comes into place. The learning objectives of this topic is as follows: define the network categorization, classify the computer networks based on a scale network. Introduction with network categories. Network categories play a crucial role in defining communication systems, structure, scale, and functionality. They help classify networks based on their size, coverage area, and purpose, such as personal area networks, PAN for close-range connections, local area networks, LAN for small-scale setups like homes or offices, metropolitan area networks, WAN or citywide coverage, and wide area networks, WAN for global communication. Understanding these categories enables efficient network design, optimal resource allocation, and effective scalability to meet specific needs, from connecting personal devices to supporting large-scale enterprise operations and global internet services. The linking of 2 or more networks is known as the internetwork. Distance plays a crucial role as a classification metric. Because distinct technologies are utilized at various scales based on their scale, computer networks are classified into personal area network, PN, local area network, LAN, metropole network, and wide area networks. WAN will look into each briefly. The image provides a structured overview of different types of network classifications based on the scale of intercessor distances, specifically tailored for interconnected processes. This classification system outlines 6 main types of networks: personal area networks, PAN, local area networks, LAN, metropolitan area networks, MBA, wide area networks, MEN, and DIG 10/6 Internet. It categorizes them according to the typical distance range between the processes within these networks, from as little as 1 meter to as much as 10,0,0 for the smallest scale. Personal area networks. PS are defined with an intercessor distance of 1 meter, typically confined to a single square meter area suitable for connections like Bluetooth devices that operate within proximity. Local area networks PLAN are presented in 2 scales. One that spans up to 10 meters typically within a room, and another that extends to 100 meters covering a whole building. These setups are common in homes and office buildings where multiple devices are connected over a network within a confined geographical area. On a larger scale, metropolitan area networks cover distances of 1 kilometer to 10 kilometers, encompassing a campus to citywide networks. They facilitate the connection of multiple LANs within a metropolitan area. WANs expand even further, reaching across countries with a reach of 100 kilometers. The broadest scale covered in the image is the Internet, which is described as spanning continents with distances of 1000 to 10,000 kilometers. This illustrates its capability to connect networks globally, transcending geographical and national boundaries to facilitate worldwide internet connectivity. A personal area network, or PAN, is a handy network that lets you link up all your devices around. You think of it as a personal bubble where your computer, smartphone, and other tech gadgets such as Bluetooth headsets, wireless keyboards, MICs, printers, and barcode scanners can all communicate seamlessly. It's perfect for connecting everything you use daily and within easy reach. The figure illustrates a personal area network, PN setup, showcasing various devices interconnected within a close range. At the center of this network is a desktop PC, which acts as a hub for connecting to other devices such as a laptop, a mobile phone, and a PD, a personal digital assistant, all through wireless communication indicated by the curved lines. Also, there's a digital printer linked to the desktop, possibly via a cable or wireless connection. This setup is typical in a personal or home office environment where a single user can seamlessly interact with multiple devices for various tasks like printing, data transfer, or internet browsing without the need for physical wire connections each devices. Next is LAN, local area network. A local area network, or LAN, is a private network that's kept within a single building like your house, an office, or even a factory. People use LANs all the time to connect computers together so they can share stuff like printers or pass information back and forth. When businesses set up their LANs, we usually call these enterprise networks. They're common in professional settings because they link a group of computers working on related tasks. Think of a bunch of engineers with their workstations or a team of accountants on their PCs. Nowadays these networks are fast, ranging from about 11 BCS to several hundred ABCS, and some even zip along at gigabit speeds. We have an example of a local area network LAN setup diagram illustrating how various devices are interconnected within a network. It shows two LANs, each consisting of desktop computers, laptops, a printer and gaming consoles, all linked via network switches. These LANs are part of a larger network that connects to the internet through a home router. The diagram highlights how devices in close proximity, like within a home or small office, can share resources and access the internet, demonstrating the typical configuration and flow of data within a LAN environment. This setup is typical for both personal and small businesses, settings where multiple devices must communicate efficiently with each other and the internet. The metropolitan area network spans across the city, fitting right in between the size of a local area network, INA, and a wide area network, WAN. A great example of a MAN is a cable TV network connecting households and businesses throughout the city. MANs are ideal for users who need high-speed internet connectivity and have multiple endpoints across the city or a specific part of it. They're designed to serve these urban areas with reliable and fast connections efficiently. An example visually illustrates the relationships and scale differences between various types of networks: local area networks, MANs, metropolitan area networks, MANs, and wide area networks, WNS. Several LANs are depicted as clusters of connected buildings, suggesting networks that operate within small geographical areas like a single building or campus. These LANs are connected to the MAN, represented as a larger network that encompasses an entire city. MANs provide connectivity across a broader area than LANs, but are still more localized than WANs. The MAN links multiple LANs in a WAN, indicating its role as an intermediary that can connect local networks to larger networks, spanning regions or countries, represented here by the WAN. This setup is typical in organizational networks where citywide systems LAN link various local offices, LANs, to the organization's broader network infrastructure LAN. Next, we have the wide area network. A wide area network, or WAN, lets you send all sorts of data like pictures, sounds, and videos across big areas, think entire countries or continents. It usually relies on services from regular carriers like your phone company to get the job done. Regarding the techie side, we mainly work with the first three layers of the O. These are the physical layer, where the actual physical connections happen. The data link layer, which handles the data transfer. And the network layer, which decides how data moves through the network. And yes, a WAN can be wireless too. The diagram illustrates a wide area network WAN setup, showing how various locations and services are interconnected through a centralized network. The primary site, depicted as a tall building, is connected to third-party vendors and centralized voice services, emphasizing how corporate structures might centralize communications. A data center is also linked to the internet and supports redundant voice services, ensuring network resilience and data redundancy. A virtual private network VPN connects more remote sites, such as a residential building and a smaller office, providing secure remote access. The diagram also includes typical components such as a VPN connection and internet access points, crucial for maintaining connectivity and security across the WAN. This setup exemplifies how diverse geographical locations can effectively communicate and share resources over a secure managed network. When discussing the differences between LAN, local area network, and wide area network, there's a lot more to consider than just the length of the cables. For starters, in a WAN, there's a clear separation between the network's basic communication tasks and the applications that run over it. The separation helps manage the complexity and scale of wide area networking. Also, wide setups usually involve routers that connect different network technologies. This is key because WANs often span diverse geographical areas and must bridge various local networks. Finally, the types of devices connected in WANs can vary widely, from local computers in a small office to major servers at large data centers spread across continents, which differs from the more uniform environment typically found in a LAN. Let us summarize what we have studied on this topic. The primary categories include personal area networks, pan-local area networks, LAN, metropolitan area networks, MEN, and wide area networks, when each distinguished by unique characteristics that define their functionality and usage. Computer networks are classified according to their size, the distance they cover, the speed at which they transfer data, and their geographic extent. Thanks for watching. Visit blacksnwhite.com. Learn today, learn tomorrow. Don't forget to like, share, and subscribe for more tech updates. Stay inspired, keep learning, and grow with us.